In this video, we will do problems from exercise 6.7. Question number 1. Find the non-parametric form of vector equation and Cartesian equation of the plane passing through the point 2, 3, 6 and parallel to the straight line 8 minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 3 by 1, and the line x plus 3 by 2 is equal to y minus 3 by minus 5 is equal to z plus 1 by minus 3. Now, the non-parametric form of the equation is defined form of vector equation is or vector dot product with b cross product with c is equal to a vector dot product with b cross product with c, where r is a position vector of any point P in the plane and a vector is a point on the plane which is already given here. The point on the plane is 2, 3, 6. So, a vector is equal to 2i cap plus 3j cap plus 6k cap, and b and c are vectors which are parallel to the plane. So, here you have two straight lines which are parallel. So, the drs of the vectors will be 2, 3 and 1, and the dr of this vector will be 2, minus 1 and 3. So, we can take this as our vector b, which is 2i cap plus 3j cap plus k cap, and vector c is 2i cap minus 5j cap minus 3k cap. To find b cross product with c is equal to the determinant of ijk, vector b is 2, 3 and 1, and vector c is 2, minus 5 and minus 3. Further simplifying this, I cap into minus 9 plus 5 minus j cap into minus 6 minus 2 plus k cap into minus 10 minus 6. So, that's equal to minus 4i cap plus 8j cap minus 16k cap. So, replacing all the results onto the non-parametric vector equation, we get r vector dot product with our b cross c is minus 4 I cap plus 8 j cap and 16 k cap is equal to a dot product with, so vector a is 2 I cap plus 3 j cap plus 6 k cap dot product with b cross c, which will be minus 4 I cap plus 8 j cap minus 16 k cap. The dot product of this will be minus 8 plus 24, 6 times 16 would be minus 96. So, the result here is minus 80. Therefore, the non-parametric form of vector equation is r vector minus 4 I cap plus 8 j cap minus 16 k cap is equal to minus 80. You can further simplify this by taking the minus 4 out. We can write this as or dot product with I cap minus 2j cap plus 4k cap is equal to 20. Now the Cartesian form of equation, replacing r cap with let r vector is equal to xi cap plus yj cap plus zk cap. So replacing this on this non-parametric form of equation, you get xi cap minus plus yj cap plus zk cap dot product with I cap minus 2j cap plus 4k cap is equal to 20. This, further simplifying this will be x minus 2y plus 4z is equal to 20. That's the required equation. Find the parametric form of the vector equation and Cartesian equations of the plane passing through the points 2, 2, 1, 9, 3, 6 and perpendicular to the plane 2x plus 6y plus 6z is equal to 9. This is our second question. So you're given 2 points. So let a vector, which is equal to 2i cap plus 2j cap plus k cap, and b vector, which is equal to 9i cap plus 3j cap plus 6k cap, be the position vectors of the points on the plane. Then further we can say that since the plane is perpendicular to this plane, if we take LMN, which is 2, 6 and 6, they will be the direction cosines of the perpendicular vector to this plane. So when we find the perpendicular to this plane, then that's going to be parallel to the required plane. So we can define vector C as, using the direction cosines from this plane, 2i cap plus 6j cap plus 6k cap as the vector parallel to the required plane. If our vector is a vector of any point on the plane, then the parametric form of equation is given by r vector is equal to 1 minus s, where s is a scalar quantity, a vector plus s b vector plus t c vector. So substituting all the values of a, b and c vector, we can get r vector is equal to 1 minus s into vector A is 2i cap plus 2j cap plus k cap plus s into vector B is 9i cap plus 3j cap plus 6k cap plus t into vector C is given by 2i cap plus 6j cap plus 6k cap. That's our parametric form of where our S, T belong to R. Next, for the Cartesian equations of the plane. So the Cartesian equations is given by the formula the determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, c1, c2 and c3. Now x1, y1, z1 are the coefficients of I cap, j cap, k cap for vector A, and x2, y2 and z2 relate to vector B, and c1, c2, c3 are the coefficients of vector C, I cap, j cap and k cap. So replacing this is equal to 0. So further substituting the values, we get the determinant of x minus x1, which is 2, x minus 2, y minus 2 and z minus 1, and here x2 is 9, 9 minus 2, which is 7, 3 minus 2 is 1, 6 minus 1 is 5, c1, c2, c3 is 2, 6 and 6. So this will be equal to x minus 2 into 6 minus 30, 6 minus 30, then minus y minus 2 into 7 6 are 42 minus 10 plus z minus 1 into 7 6 are 42 minus 2, which is equal to x minus 2 times minus 24 minus y minus 2 into 32 plus z minus 1 into 40. So further simplifying this, you get minus 24x plus 48 minus 32y plus 64 plus 40z minus 40, which is equal to minus 24x minus 32y plus 40z plus 72. This implies minus 24x minus 32y plus 40z plus 72 is equal to 0, which implies we can take 8, which is common to all. This equation will become 3x, dividing it by minus 8, 3x plus 4y minus 5z minus 9 is equal to 0. This is the Cartesian form of the equation. Question number 3. Find parametric form of vector equation and Cartesian equations of the plane passing through the points 2, 2, 1, 1, minus 2, 3, and parallel to the straight line passing through the points 2, 1, minus 3 and minus 1, 5 and minus 8. So the position vectors of the points on the plane is 2i cap plus 2j cap plus k cap is equal to vector A, and I cap minus 2j cap minus plus 3 k cap is equal to vector b. And also the line which is parallel to our required plane passes through the points 2, 1, minus 3n, minus 1, 5, and minus 8. Therefore, the equation of this line can be written as the equation of the straight line passing through the points can be written as x minus x1. Let's take x1 as 2, 1 and minus 3 as x1, x2, x3. So 2 minus 2 divided by our x2 minus x1 will be minus 3, which is equal to y minus 1 divided by 5 minus 1 will be 4, and z plus 3 divided by minus 8 plus 3 will be minus 5. Therefore, this line is parallel to, you can say is parallel to vector c, which can be defined as, using the direction ratios, minus 3, 4 and minus 5. So minus 3 I cap plus 4 j cap minus 5 k cap. Now the parametric form of equation is R vector is equal to A vector plus S times B minus A vector, where S is a scalar quantity, plus T is another scalar quantity, into C vector, which is equal to, substituting the values of A vector, B vector and C vector, we get 2 I cap plus 2 j cap plus k cap plus S into our B minus A will be 1 minus 2. So it's minus I cap minus 4 j cap plus 2 k cap, which is plus T into our C cap. C vector is minus 3 I cap plus 4 j cap minus 5 k cap, where our ST belong to R. So this is our parametric form of the equation. Next, the Cartesian form of the equation is given by the Cartesian equations is given by the formula x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, c1, c2, c3 is equal to 0. Now substituting for x1, y1, z1 is vector A, coefficients of I cap, j cap and k cap. Similarly, x2, y2, z2 relate to vector B, and c1, c2, c3 relates to vector C. So substituting, you get x minus 2, y minus 2, z minus 1. Then you have x2, which is 1, minus 2, which will be minus 1, and minus 2 will be minus 4, 3 minus 1 will be 2, then c1, c2, c3 is minus 3, 4 and minus 5. So this is equal to x minus 2 into 20 minus 8. 20 minus 8 will be 12. minus y minus 2 into minus 1 minus 5 will be plus 5 plus 6. So that will be 11 times 11 plus z minus 1 into minus 1 times 4 is minus 4 plus 12. So 12 minus 4 will be, sorry, it will be minus 12 minus 4. So minus 16. So this is equal to, further simplifying this, you get 12x minus 24 minus 11y plus 22 minus 16z plus 16. Further simplifying this, it is 12x minus 11y minus 16z minus 24 plus 22 will be minus 2 plus 16 will be plus 14. Now this is equal to 0. So further you can rearrange this as 12x minus 11y minus 16z plus 14 is equal to 0, which is the Cartesian equation of the required equation.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.